Okay, hi everyone. Welcome to developing an observability strategy. So my name's Alex. I'm a specialist solutions architect specializing in observability. Done just about over 20 years in IT. Got a 7-year-old daughter. I used to play Ultimate Frisbee, but I got too old and a bit too fat as well. So now I try and play golf instead. So we're going to talk about how to design an observability strategy, and we're also going to go into a few technical things as well.
Hi, my name is Anya De Valta. I'm also a specialist solutions architect on the cloud operations team here at AWS. I have been in IT for over 20 years as well, 3.5 of those years here at AWS. I'm a mom of 2. I've got a 20 and a 15-year-old daughter, or daughters, and also I'm a cat lover. I actually have 4 cats and 2 dogs, and I don't stop talking about them, and they actually feature in our observability workshop. That's how much I love them.
Hi, I'm Igor Sadugin. I'm a general manager for application observability at AWS. I'm a lucky dad of one great 10-year-old daughter. And I love snow, so I get to do it quite a bit when I get back. Seems like it's dumped. So talk a little bit about observability. If there is any business of value that has to perform to expectations, it pretty much has to be observed. And so observability has to deliver and scale with your business needs to billions of runtime instances, to millions of users. It needs to be there when you need it the most. So it has to be as available or better than what it observes. And more importantly, it actually needs to make your life and cloud operations simpler. And so we'll explore that aspect of how do you approach that? How do you make it simple? So before we launch into the session, let's talk a little bit about the context in which observability exists, cloud operations. Where in AWS lifecycle would you encounter the need to observe something? So first, you're highly likely to set up your environment for compliant operations. So create your AWS organizations, set up IAM roles, make sure you have compliance controls in the environment. That was the first step. Second, you're migrating or developing an application, maybe a serverless application directly in AWS. And you'd use CloudFormation templates and all different tools that we have to develop that application. Once the application is in production, you would highly likely need to observe and see if it performs as expected. And that's where you would encounter tools, a family of tools in CloudWatch, to be able to observe and explore your application as it runs and serves users. So let's get into it.
Okay, let's talk about the important metrics. CPU, RAM, and disk metrics are the core measurement of any system. Even serverless services run on servers, right? Yes, these metrics are important, but are they actually important to your business and your application? You should only worry about those metrics for the purpose of cost optimization, scaling, or capacity management. But should you care about these metrics? Do they tell you anything about how your application is running? Or more importantly, and do they give you any insights into your customer's experience? Now, we're going to break from convention here and ask you to get your phone out and follow the QR code that you see on the screen there. It'll take you to a very simple film website. We just ask you for you to just browse around, maybe search for a film by year.
Yeah, and sorry, this is very basic. You can blame me, I've built this. But it's going to serve a purpose.
Okay, so whilst you're browsing around, we would appreciate some audience participation here. Tell us about the metrics that you care about in your organization, and there's no right or wrong answer here.
So anyone, shout out what's important. Yeah. Latency we've got.
Anyone else?
Response time and throughput.
Thank you.
Lack of errors.
Freshness.
Freshness.
Usage of data.
Hits per second.
Sorry?
Hits per second. Hits per second.
Hits per second. Thank you. Anyone else?
Another one about failures. Didn't quite.
Price, did you say?
Sorry?
4x, 5x.
Yeah, 4x and 5x errors, yeah.
Hold on. This gentleman, I can't hear him.
Cost.
Oh,
Yeah, cost.
sorry. Thank you.
Very important.
Igor, do you want to tell us more about the metrics that your team cares about?
Yeah, exactly. At AWS, we run services for you, and this is one of the most important questions we actually ask our teams. What is the most important metric for the business that service performs in relation to you as a customer? And so, as was mentioned, tends to be things like, does the console load? Is it available for you to use it? Is the latency of the APIs or of the user experiences adequate, right? And is availability adequate? And so what we do, well, with that metric is we in fact have a company-wide meeting every week where we spin the wheel. I know maybe you've read about it, and there's AWS wheel. And it picks the service, one or two, that will show to the company what metrics they observe and whether or not the operations are healthy, right? And we do this kind of friendly inspection of each other to ensure that these metrics, the key metrics that we observe on your behalf, right, are actually indeed serving the needs of that business, of that service serves. So this is the most critical question.
Okay, and what about Amazon.com, Alex?
Yeah, so I guess the most important metric in terms of Amazon.com or any of our other retail sites is how many orders are we getting, how many orders are we processing. And if that falls below a certain threshold, then we know that there's a problem. And this should become obvious why we're talking about this and why that's an important metric.
Okay, so we're going to take this back to the context of that film website that you just browsed. So if you're still browsing, you can stop searching for films now. Thank you. And Alex is going to show you the metrics that we care about.
Okay, so here I've got a dashboard, and I'll just go through what we've got on this dashboard. So we care about availability. We've got 100% availability. That's all good. Then I've got some SLA statuses here. So there's three SLAs here. Availability SLA. We've got page load SLAs. We want 99% of our page loads to happen within 2 seconds. And we've also got an API response SLA. So we want our APIs to respond, again, 99% of them to respond within a second. I've got some other metrics here that I care about. So I've got sessions in the last hour, searches in the last hour. So these are other kind of important, would be important business metrics if the website that you looked at was a business. So when we look at our page load times, I've got these separated out into different percentiles. Our percentiles are really important. If you don't use percentiles, averages can hide problems. So we can see here at P50, and I'll explain what that is in a minute, we've got 850 milliseconds for page load time. Great. So what this means is that 50% of our users, the maximum page load time for them is 850 milliseconds. At 90%, it goes up to over a second. And at 99%, it goes up to 18.8 seconds. That's definitely above the 2 second mark. And we're using CloudWatch Real User Monitoring to get some of this data. And what I have here on the right-hand side is metrics that come directly from Real User Monitoring. Let me try and get rid of that. So we've got the percentage of page load times that happen under 2 seconds. We want that to be above 99%, but it's 96.7. We've got some of them 0.25% happening between 2 and 8 seconds, and we've got 3% that are over 8 seconds. So there's something wrong. We'll look at this later. I've got some metrics here from Load Balancer as well, and these metrics are basically the same metrics, but they're from our API. So again, if we look at 99%, if we look at the 99th percentile, so that's the maximum response time if we take into account 99% of the requests, it's 25.2 seconds. Again, this is really bad. And then the reason we ask you to log on and have a look and play around is to show you these metrics as well. So you can see here at the top we've got 47,000 requests coming from the US. Some of those, or a lot of those, and you'll see a lot of these at the top, they're coming from some containers that I've got running in the background generating traffic. But it looks like some people are using SIM cards that are going back to their country, because we've got, looks like Canada and Australia, I think. And then we've got browsers as well, and operating systems. So what we've got 2.25 thousand hits from Android and 2,000 from iOS. So put your hand up if you're using an Android phone. And who's using an iPhone? Yeah, so I'd say that was roughly about half and half. So we know that worked, which is good. So this is a kind of dashboard of the things that I want to see if I'm running this very basic site. We get some of this information from real user monitoring. So I'm just going to take you through real user monitoring very quickly. And this also demonstrates why averages are sometimes not good. So we look at our average load time. It's 1.7 seconds. That seems like it's under our SLA, but as you saw from the percentiles, it's not. So again, definitely use percentiles. Then we've got data here. This is Web Vitals data. So this gives us data about load performance, first input delay, so that measures inactivity, and cumulative layout shift, so that measures how visually stable your page is when it loads. And then we've also got a breakdown of what happens when the page is loading. So for our site here, time to first byte is the biggest, and DOM processing time. So we could use this information to maybe cut down on the time to first byte and DOM processing time. And we can look at this by browser and device. And I'm just going to show you quickly the configuration, because all you need to do to enable this is this JavaScript snippet here. You just add that into the head of your pages. Okay, so I'm going to go back to the presentation.
It would be interesting to note that one of my teams actually is RUM. So RUM is the team inside of the application observability organization. And we use RUM ourselves to observe RUM to know whether it performs well for you in a very similar fashion, where you can see the metrics of page load or reaction time, and then we're able to trace it back to the service behavior. So we use our own tools to make sure our services run well for you.
Okay, so this is Amazon's vision. So it's our vision statement. And we strive to be Earth's most customer-centric company, Earth's best employer, and Earth's safest place to work. Why am I talking about vision? So anything that any of us do, so any of us on stage, or anything that any of you do, anyone in this room, it should all align to your organization's vision. So all of us are really, basically, we're all employed to fulfill the vision of our organization. And for us, like I said, that's to be Earth's most customer-centric company. And the way that we strive to be Earth's most customer-centric company is by starting with our customers and working backwards. So when you think about observability, you should think about what your customers want and what they need. And customer obsession is also one of our leadership principles, and we say that leaders start with their customers and work backwards. It's really fundamental to us, but it's also really fundamental to how you should think about observability. So we want to care, we want to think about what do our customers care about? What do they need? What do they want? And these are basically some examples of what customers generally care about. In this case, it's in the context of an e-commerce site. So, all of you, I imagine, have used an e-commerce site, hopefully ours. And you care about things like delivery. You want your stuff to be delivered quickly, or at least know when it's going to be delivered. Obviously, everybody cares about the price. You care about security and privacy. You care about how long the page takes to load. And you also care if you can find the product that you're actually looking for. And things like page speed really affect the business. So a 2017 study showed that 53% of mobile users will just abandon a page if it takes more than 3 seconds to load. And I'm just giving that example of a thing you need to think about in terms of how metric observations can affect business outcomes. So once you've kind of thought about what your customer requirements are, you need to map these requirements to stakeholders in your organization. So you need to talk to them to understand the metrics that they care about that could impact customer requirements. And this is because we might not know, right? As technical people, we might not know what the customer requirements are, but the stakeholders, it's their job to know. It's their job to care about what the customers care about. And it might seem easy for something like an e-commerce site. Probably most of it seems obvious. But I'm going to give you another stat now. So there's a Forrester research report that said 43% of visitors, when they go to a site, they'll go straight to the search. And searches are 2 to 3 times more likely to convert compared to non-searches. So search is really important, and it has to work really well. And a bad search experience will take people to another site, and it's going to impact your business. Another example might be that a logistics manager, or again a product manager, might understand the impact of an item being out of stock. Obviously, if an item's out of stock, or it has a long delivery time, people are going to be less likely to buy it.
Okay, so this might sound familiar to most people in this room, but very often business stakeholders pop up and ask questions that actually relate to metrics in your application.
Okay, so Anya, can you tell me how many customers are abandoning their shopping carts because the delivery time was too long?
I'll have to look that up for you, Alex, so I'll have to get back to you later.
How much does it cost to run?
Igor, I am in the middle of a really important project. I will have to get back to you later.
How many attempted attacks have we had in the last month?
I'll get back to you shortly. I believe we do have that data.
How long does it take to load our front page?
Let me check my phone.
And how many times are we producing no search results when somebody searches for something?
We don't actually record that data, Alex. I'm sorry.
Really?
Okay, does this sound familiar? It's like a game of whack-a-mole. Finance asks how much, a product manager will ask how long to release a feature. But how do we get this information to your stakeholders? How do you even know what data to collect? You work backwards from the customer. Okay, so you want to make sure that your customers have a great customer experience. So you start with those customer requirements and work backwards. You then work with your stakeholders because they understand those requirements really well. You then work together to derive KPIs. Once you have those KPIs, you identify metrics, which you then collect. Once you have the metrics, you can alert and you can act when business outcome or customer experience is at risk, And then once you've had to act, you then make improvements based on what was wrong. And that in turn improves customer experience and creates this virtuous cycle of continuous improvement and continuous improvement of customer experience.
And what's really, really important here is you can't do continuous improvement or generally make improvements to your products or your applications without this data, unless you just happen to get lucky, which can happen, but don't rely on luck.
Yeah, you can't improve what you don't measure, so that's important.
Okay, so now that you understand why you need observability, how do you go about it? Now this is key, you need to develop a strategy. So first think, what do I collect? So we already talked about how important customer obsession, customer requirements are, how important it is to work with those stakeholders and to derive those KPIs. And the KPIs will inform you what you need to collect. And then next, you need to ask yourself in your strategy, what do I observe? Well, first, you're going to have to identify the sources of the information, of those metrics, all those things that will help you measure against those KPIs. Now, these could be in multiple places, but typically you'll find them in either metrics, logs, and traces, or all of them at once. But it's really important that the data that you care about the most is that data that gives you insights into your customer experience. Once you have that data, you then develop a strategy on how do you act. You need to develop an alerting strategy so that you are aware when outcomes are at risk. You also have to evaluate business impact, and you also have to plan or at least define a strategy of how you intend to act and what your expectations are. And your strategy should allow you to observe your application based on its purpose to your customers.
Okay, so as well as having this strategy, you need to have a plan. How do I go about doing this? So when you're designing your strategy, these are basically the steps that we think you should take. So work backwards from your customer. Again, I'm going to repeat that. Work out what they want and what they need. Talk to the stakeholders that represent the requirements of your customer, because they know what your customer needs. And that will help you to identify your KPIs. You can then use those KPIs to identify where you're going to get the data from. And you might need to extract this data if obviously you're going to need metrics, and you might need to extract this from logs or traces. And from there, build stakeholder dashboards to reflect these KPIs. Then you don't have to play this whack-a-mole game. And then design your alerts for when business outcomes are at risk. That's the critical thing. And then you need to design or use an existing alerting strategy that classifies impact and severity. So obviously things like business impact, business critical impact, business critical severity, and you might have low impact and low severity. And you also need to route alerts to people that can actually fix issues or make a decision. Every single alarm that you have should have a plan, so either a runbook or ideally for a technical issue that should be automated or at least semi-automated. And when you've got non-technical issues, you should still alert stakeholders. For example, if you've got a drop in orders in a certain country, you may want to alert the country manager that manages that country to let them know that they've got a drop in orders. Okay, so we looked at some generic metrics on the dashboard earlier around like page load speed and response time. In the bottom right-hand corner of this slide, you'll see a chart that shows our search results being returned from our site. Now, technically, this might not seem like an important metric. Why do we care about this? It doesn't tell us if our application is running or not. And this is what we're talking about in terms of, it's not about CPU, and RAM, and disk utilization. So search is really important to this particular business or this application, this films application. And if people are searching for something on your website and you don't have it, well, maybe you should have it. Or maybe people are commonly misspelling a product and it returns no search results. And then you might want to rethink your search algorithm. So you might want to go from naive pattern matching to natural language processing. So I'm going to talk a little bit about how we made this graph. So this is using CloudWatch Contributor Insights. And this analyzes specific fields in log events. And this allows you to identify outliers. This could be expensive if you had to slice and dice all of this information. And in fact, I've already spoken to 2 customers this week, and they had both had perfect use cases for using Contributor Insights. Wanted to look at millions of devices, and they wanted to know or be alerted when they were having lots of errors with a specific device. Now that would be hugely expensive if you were collecting metrics for millions of devices. But by using Contributor Insights, you can slice and dice this information at a much lower cost. So in this case, we're using it to count the total number of searches for each year that's being searched for in our application. Because we have a finite number of years to search, we can identify searches that aren't yielding any results. So if you searched for a year, I can't remember which ones yielded no results, but let's say you searched for 1947 and you didn't get any films from 1947, but you really wanted to buy a film from then that would be bad news. We might want to do something that wasn't technical, but something business related to improve it. And we use this a lot internally as well. So how do you go about doing this?
Correct, Alex. So all of our services serve millions of customers, right? And we observe percentiles of aggregates, of course, to make it available or compute latency. But it is very important for us to understand the specific issues or behaviors of each individual customers, and we deploy this approach to understand the outliers. Like in a big set of customers, there may be one who experiences particularly long latency because one of the services could have had a stuck partition or an instance, right? And so we deploy this approach ourselves to understand, and better manage services for you to make sure we understand each of you, not as an average, but individually. So.
Okay, we're going to talk about designing dashboards next. So we've added a QR code to an Amazon Builders library called Building Dashboards for Operational Visibility. You should check it out. It's a great article. Okay, so when designing your dashboarding strategy, we already talked about stakeholder dashboards. And those stakeholders typically come to you, and it's always at the most inconvenient time. You're in the middle of a project, and they always need the data straight away. And it's important for them. So when you're designing your dashboards, keep in mind those stakeholder dashboards. They are really important. So examples there would be a cost dashboard for the CFO, or a service audit dashboard for the CISO. But the goal of a good observability strategy is to detect issues before they affect your customers. And dashboards are that human-facing view into your system that summarize your system behavior. And this is why you need those other high-level dashboards, those more application-specific dashboards, such as customer experience dashboard or a system or a service-level dashboard. Okay, so the main reason for this talk is to create an observability strategy centered around your customers. But those technical dashboards are also important and can also affect business. And this is why you also need to design those low-level dashboards, those dependency dashboards, infrastructure dashboards, microservice dashboards. And this is where you will see those CPU, RAM, and disk metrics. Now on to designing alarms. So when you're coming up with your alarm or alert strategy, be very deliberate about what you alert on, because this will have a massive impact on your business outcome. If you alert too little, you will lose visibility. But if you alert too much, you could also lose visibility. So first, define a strategy. What is a warning? What is an alarm? And what should be an actionable alert? Now, alert must be actionable. Why would you alert if you don't want to take action? So I always apply that 3 a.m. rule to all the alerts. If you got that alert at 3 in the morning, would you read the information and turn over and think, I can sort that tomorrow? Perhaps that shouldn't be an alert then. So also make sure that those notifications are meaningful and that they are received and routed to the right people. And then define the expected actions with the use of playbooks so that anyone who's responsible to responding to an alert, no matter how long they've been with the organization, how well they understand the business or the application, it's so that they know exactly the process that you expect them to follow. And then where possible, remediate with the use of runbooks for automated or semi-automated remediation. Now, alert fatigue and alarm noise can be a real business impacting issue, because if you have too many alarms, it is really easy to miss something important. So where possible, create meaningful alarms. So in CloudWatch, we've got composite alarms, and they allow you to use and or not operators to combine multiple metric alarms to create those more meaningful alerts. So for example, a lower number of orders might be okay, but actually if it's at the same time there's a lower number of search results, that might indicate that there is a customer-facing issue in your application. So by using an AND operator and a composite alarm, you can be alerted when the thresholds for orders or for search results fall below a certain level. So you will only be alerted then as you understand that there is a correlation. So you don't need to know when just one's below the level, both are below the level. Now, another feature of composite alarms is alarm suppression. So here you can create an alarm, for example, to indicate there is a deployment in progress, and that will act as a suppressor in the composite alarm. And when that suppressor alarm is in the alarm state, any other alarm in that composite alarm is suppressed, no alert is generated, and no action is taken. And you can also nest multiple composite alarms for those complex scenarios, such as disaster recovery. And then lastly, one other way to reduce alarm noise would be to leverage anomaly detection alarms in CloudWatch. Now, these don't have those static thresholds that you set yourself. Instead, they follow or they alert or alarm when that value falls outside of the expected value that's based on that anomaly detection model.
Okay, so I'm going to do another quick demo. Cool. Okay, this one's going to be pretty quick. So I've highlighted some alarms here already. So I've got 3 CloudWatch alarms here. I've got tolerated or frustrated navigation. This is basically when real user monitoring is telling me that I've got a page load speed of either between 2 and 8 seconds or above 8 seconds, which is the metric I showed in the dashboard at the beginning. I've also got an alarm that's telling me if I'm being throttled by DynamoDB. And then I've got a special type of alarm here that says DynamoDB throttling affecting page load time. And this is a composite alarm. And this is what the composite alarm looks like. So it contains the child alarms, so the tolerated or frustrated navigation and the DynamoDB rethrottles. And there's my alarm rules. So this is what Anya was talking about, of having and or ors or both in the rules. So you can see as well the history of this alarm. This alarm has been going off a lot, and we'll talk about that. And then I'm just going to go to a dashboard that kind of shows why we might use this. So at the moment, one of these alarms is going off. So we've got DynamoDB read throttles going off. Put your hand up if you had a really slow page load when you accessed the site. Anyone? Yeah, cool. That's on purpose. So we've got some DynamoDB read throttles, and this is a graph showing the alarm, and we've got tolerated or frustrated navigation. We've got another graph showing alarm. So I then correlated this, and this is in the bottom left, and you can see that the correlation is not immediately obvious. So what I actually used is CloudWatch metric maths to multiply the frustrated navigation by 10. And the reason behind that is when the application is calling DynamoDB and it's being throttled, it will attempt to retry up to 9 times. So if I multiply it by 10, we should see roughly the correlation. And here you can see we've got this correlation. When we're having read throttles, we're getting this poor navigation experience. And when both of these alarms go off, so either side of this middle one, that will then cause this alarm in the middle to go off. And that's what I care about. I might not care if we get the occasional amount of read throttling or the occasional frustrated navigation, but if one is causing the other, I really want to know about that so I can fix it. And we will do that in a minute.
So this is something, by the way, we practice ourselves quite a bit to reduce alarm noise. Is anomalies by themselves are not really worth looking at. It's very important to understand if they're in the context of something that relates to a customer experience. That really helps our teams deal with just volume of alarms.
Cool. So once you have a metric and you've identified, you've got a problem, like we've done just then, you've got to rate against time. And in a distributed system particularly, how do you find out quickly why there's a problem? And part of being able to do this is having a good logging and tracing strategy. Having data from distributed systems in one single console is going to help you get to the root cause more quickly, rather than having to look in numerous different places or even having to log on to instances and see what's going on. So there's a couple of things you can do once you've got all this as well. You can use services which offer additional insights. So we've got things like, you've seen contributor insights. We've got container insights, which gives you some more information about containers. Lambda insights, which gives you more information about your Lambda functions. And then we've also got Service Lens, which is a great place to start to visualize issues which have been correlated from your metrics, traces, and logs. And the key thing is here that a metric and an alarm tells you that maybe you've got a problem, but it doesn't tell you where the problem is, and that's where you need logging and tracing. So logging and tracing help you get to that root cause more quickly and hopefully either reduce the impact or get rid of it completely. And as I said, metrics help you. They may help you identify an issue, they may help you with predicting trends, but it's logs and traces that complete the picture. And I'm sure we all know what logs are, but I'll say it anyway, they're an immutable record of an event that's taking place in your application. And we've all, I'm sure, looked at logs to try and investigate why there's been a problem. And that's one place where you can deep dive and find out why there's been an issue. Traces, on the other hand, they take either a user-centric view or a transaction-centric view of the path a request takes through your services. And they can tell you the impact either to the path or to the user. So we've got a couple of examples here. So in this logs example on the left, this is from an Apache web server, and I'm just looking for events with 403 or 404, and this might tell me potentially where I've got bots coming to the site. And this is where it's also important to use, if you can, to use structured logs. And in the case of Apache Web Server, and there are lots of other applications like this is a one-line change to the config file in Apache Web Server to enable structured logs. And this makes it much easier to query your logs, to use contributor insights, and also to extract metrics from your logs. And you can do that using log metric filters. And traces kind of stick all this information together, and they allow you to correlate business transactions with events. So I'm going to do a demo now, troubleshooting why we've got this issue. Okay, so I hope you can see this. We've got a service map here of our application. So just very quickly, it's a pretty basic application. There's pretty much 2 or 3 parts to it. We've got some EC2 instances behind a load balancer in an auto-scaling group. And basically, they call DynamoDB, and that's where the films are. And then we've got an API, which basically does the same thing, and that's using an API gateway, going to a Lambda function that's also making calls to the same DynamoDB database. On this map, we can look at metrics as well, so we can look at average latency. So the average latency on my EC2 instance is 514 milliseconds, and we've got 72 transactions per minute going on. I can even click on a link going between 2 nodes on the map, and that's going to show me the same kind of metrics. So in this case, it's error rate or OK rate. In this case, everything's OK, 100% OK, and the transactions per minute between the 2 nodes. But what we're going to do now is troubleshoot, and we can see from the legend here that if I've got red, that means I've got a fault. So I'm going to click on this API gateway, and we can see now immediately we've got some metrics with for latency, for requests, and for faults. And we can see we've got a lot of latency and we've got a lot of faults. And you can see that they line up, right? The latency lines up with the faults. So what we can do from here is click on the faults and go to View Filtered Traces. So it's automatically filled in a search for me, and I can see a list of all of the traces that have resulted in a fault. And now I just need to go to one of these, and I immediately go to an overview of this individual transaction that's taken place. In this case, it's a synthetic canary that's done the transaction. It's gone to the API gateway, gone to the Lambda function. There's a call made to the DynamoDB service, and there's a call made to my DynamoDB table. We can then start to look at what's happening. Why have we got this fault? So the fault is exposed in the canary, but it's actually downstream. Exposed in the API gateway stage, but it's actually downstream. And it's downstream in the Lambda function, and it's when it's calling DynamoDB. So when I look at this in more detail, I can get an overview here of the trace and when it happened. But the key here is when I go to exceptions. And this exception tells me exactly what went wrong. So I've gone from a service map, just doing a few clicks, and gone right down to the error message. So I get an error here, and it's telling me, basically, I'm being throttled by DynamoDB. That's my issue. It also tells, I've also got a stack trace, and that tells me exactly where in my Lambda function the problem's occurring, so I could look at the code if I needed to. In this case, I don't need to because I know it's a throttling issue. We've also got correlation here, so we can also see every single log event that happened that's been correlated with the trace ID. And if I expand one of these, you'll see I've got that same error occurring in my log as well. So we can now look at DynamoDB, and we can see here this chart on the very left shows how much provisioned capacity I've got, which is 1. and then how much consumed, which is the blue line, which is way above it. So it's peaking at about 3, and I've only got capacity for 1. And this is causing lots of throttling requests. It's pretty much throttling all the time. So all I need to do to fix this is go to the settings and edit these capacity units. I could edit it, set it to 10. I could also do some other things. I could set it to auto-scaling or set it to on-demand. That would also fix it. Click Save, and within a minute or so, that should completely fix the issue. Obviously, things aren't going to be this easy all of the time, but essentially what I want to show you is that you can go in this service lens map from having an overview of your application, seeing where there are faults or errors, and then drilling down into the individual traces and going straight to an error or a stack trace. And nearly forgot to do this. X-Ray Insights also automatically discovers anomalies with your traces. So here, Insights has discovered that we've got this problem. It's even established the root cause of the issue. And if I click on this, I can see the root cause details. So this is giving me a map. This might be difficult to see, but it's giving me a map, and it tells me here the root cause, and it tells me that it's DynamoDB. And okay, I'm going to go back to the slides.
One other technique, just to mention, that we use commonly to help with logs and traces. Alex talked about Apache logs, system logs, and then traces, is to send in or upload your own custom events, the business critical events, say purchase completed or user deleted or whatever, and then they actually really help in your investigations, because then all that process is otherwise looks 8 talks to B. Now you can contextualize it quite a bit.
And also, just to add to that, when you're doing tracing, you can add annotations to traces. So things like, if you want to add a customer ID or something like that, you could add that to your trace. So now you've got your metrics that your stakeholders care about that reflect what your customers care about, the customer experience. And you've got dashboards for your stakeholders. They don't have to wait anymore. You don't have to spend your valuable time trying to find these metrics or running reports for people. You've added traces to help troubleshoot issues and get to the root cause quickly. And you've also added you've also added important metrics so you can help identify potential issues. I thought I hadn't done the animation, and I think it had. So everybody's happy and everybody's smiling.
Okay, so the key takeaways from today's session. Although those CPU, RAM, and disks, and other technical metrics are important, they don't tell you anything about the customer experience, or they don't give you any insight into that. So your customers are what's important, and their experience is what you should be monitoring and observing. This is why you should work backwards from your customers, work with your stakeholders, derive those KPIs, and collect metrics that actually matter.
And look, if you're going to take away one thing from this session, it's speak to your stakeholders, even if you have to force them to speak to you, to find out what matters to your customer, because that's what you should be observing. Right, just on a side note, we have a new observability training course. We released it last week. It covers an introduction. It covers about how to use the CloudWatch agent, so how to install it, how to configure it, some of the alerting and insights that we've showed you, more into application monitoring and all the application monitoring tools that we have, and also some of the open source tools that we have as well. I might be biased because I created it, but it's well worth going and having a look. Please complete the session survey. We're also in the expo, So we're in the Cloud Ops section, and we've got an observability stand there. And that QR code points you to other observability sessions. And yeah, thank you very much. Again, please don't forget to fill in the survey. And we'll either be here until we get...